Hello! Are you ready to write some more complex smart contracts using the tools that you've learned over the past few episodes? Now before you begin, make sure you subscribe to the channel and share it with other people who you think will find this content helpful. My goal of this channel is really simple, to teach you skills that are highly in demand, highly sought after, and I'm not making any money out of this. My video don't even have ads turned on. So I'm really just hoping that you do me a favor, subscribe, share the link to others on social media. Now today, the smart contract we'll be building would introduce a few new features of Solidity. It implements its voting contract and it's also straight from the Solidity documentation. The main problems when it comes to electronic voting is how to assign voting rights to the correct persons and how to prevent manipulation. Now we will not solve all the problems here, but at least we'll show you how delegated voting can be done so that vote counting is automatic and completely transparent at the same time. More importantly, there is no double voting using this mechanism, and it will test our contract to guarantee its integrity, at least from a blockchain engineering perspective. And you can also think of voting in the context of elections, committee, DAOs, DAOs, which stands for decentralized autonomous organizations, and anywhere where trust on a decentralized community or society is scarce, and that there is a requirement for a trustless mechanism to collectively have people exercise their rights, and we will reflect this also in a smart contract using these weights. So you can think of it like having a chairperson having a little bit more weight, so the vote would count as 1.3 maybe, and then a committee member would count for 1.1, and then a regular member will count for 1. So we'll implement that in our smart contract as well. The idea is to really just create one contract per ballot, providing a short name for each option, and the creator of the contract will serve as the chairperson, will give the right to vote to each address individually, and the individual can then delegate the vote and say, okay, I'll delegate my vote to this other individual. In other words, the persons behind the address can choose to either vote themselves or to delegate the vote to a person whom they trust. So how do you have all of this packaged up in a smart contract? Are you ready? Let's get started. So if you're ready, why don't you open up your IDE and let's get started. So in the last few episodes, we have the C1, we have contracts in here, we have coin, we have simple storage, and then we've written our tests. Now we're going to go into contracts and we're going to create a new smart contract. You can do it through the terminal, just touch contracts, new file, or you can just right click and then just put new file in there, right? So let me just say touch contract. Let me make sure that I have, so let me change directory to C1, and then I'm going to just quickly touch contracts. And this, we're going to have to give it a name. So we're going to call it Ballot. Right, ballot.so. So that is being created. We didn't put them in the right contract, so we're gonna have to move them. So move ballot.sol into contracts folder. There we do it. So just create that in the right folder in the first place, then you don't have to do this move. Okay, so now that we've done that, you're gonna just have to close this down a little bit. And in your terminal, you can just Control P and search for it, ballot.sol. So this will bring up Ballot. Now this is completely empty because we haven't actually done anything for it, right? So what we need to do first is to make sure that we have the same license identifier, and then we have a pragma that will tell the compiler what version of Solidity to be using. And really quickly save it so that that error goes away. And now we're ready to start. So first thing, gonna turn off the sidebar, so we don't need the sidebar. And we can readjust the window size a little bit. And we're gonna go ahead and just create our contract. So we say contract Ballot, just like this. We learned a couple of things from the last video. The first thing you know is that we almost always want a constructor. The constructor is only going to be called once, which is when you first deploy the contract. It's going to be initialized when you first deploy the contract. So in here, let's go ahead and create our constructor. And within it, we can have a quick, sort of like what we did in the last video. We have the minter and we set that to be message to sender. But in this case here, we're not going to call it minter anymore. We're going to call it something else. We're going to call it a chairperson. So we have chairperson, and we say that's going to be whoever that deployed this contract. So message to sender. Okay. So when you first deploy the contract, that's message to sender. We say, hey, take that and then assign that person into chairperson. Now we don't have chairperson, so let's go ahead and create that. Right up here, we didn't. After contract, let's go ahead and say create a variable public chairperson, because we want anyone to be able to query for that and get a result of this. So when you see public, what happens is Solidity is just going to implement the getter for you. So you can then create ballot equals ballot deploy, and once you deploy that, you can then just call chairperson, spell it correctly, and you can just call for that and we return who is the chairperson. So the chairperson is only going to be set once, which is in the constructor, and that's going to be whoever deployed the contract. So I want you to recall that everything you create here these variables that you create up here that is not within a function, all of these are state variables. They are in the storage. Storage meaning what? Meaning they're stored on the blockchain. So all of these are storage, right? They're stored on the blockchain. These are values that anyone can query and it would exist, and you can mutate the value, you can change the value, and all of this would be done using this thing called a transaction, and every transaction has a gas fee. You pay for the gas fee, and then you modify the state of the blockchain, modify the state of the contract. That's the storage. So let's go ahead and think about what kind of state variables do we need here. So we do have the chairperson. This is just going to be an address, so that's just going to be a variable here. But what else do we need? Well, maybe we need the voter. If we don't have voters, we can't really vote on any of these proposals that came through, right? So the whole point of doing this ballot is actually to have voters being able to vote on proposals that they like in favor of or against. So let's go ahead and say struct. Now I know that we haven't really talked about struct, so let me kind of write the syntax out and then explain to you what this is doing. Structs is a complex type, and in Solidity, when you use struct, you're usually using it to create your own data type in the form of a structure. And the struct contains a group of elements, so you can have different elements within struct, and all of them, they don't have to be the same data type. So you can have one element here being a unsigned integer, and you can have another one just being a string, can be another one being a boolean, and they're usually used to represent or to group a set of records. Okay, so voter looks like this, and you can think of a few examples of structs. For example, I can have another struct up here. Just ignore the warning for now. I can have something like to-do item, and within it I will have a string, and this is the to-do task, right? And within to-do struct itself, I also want to have a boolean of saying that whether this is scheduled, and I can also have something like a boolean whether this is done. Make sure you put a semicolon at the end of each of this. And so this is a complete struct. It does have a string, it does have a boolean, it does have another boolean, and it's saying that if I create a to-do, it would have a string name, which is the task itself, and whether or not it's scheduled or whether or not it's done or completed. So whether or not it's completed, for example. Okay, so whether the task is already scheduled. So if it's scheduled, means I can actually work on it now. If it's not scheduled, meaning okay, there's some to-do item and I don't have to worry about that now. Just put them on the list there and know that I will have to come to it at some point, but it's not scheduled yet. So it can be something as simple as that. What about voter? What do we have for voter? Now for voter, we want to make sure that each of them has an address. So you want to first have an address, and you can call this the delegate. So the address is just the delegate. So whoever is delegated to run to vote for this, it can be himself, it can be herself, or it could be somebody else. All right. So this is whoever person who is delegated to vote. And then we also have the vote itself. So we want to have the vote itself. So this is not actually the number of vote, but this is actually the index of the voted proposal. So somebody could put forth a proposal. In this case, let's say we have proposal A and B, proposal A, and we have proposal B, and so this will be the index of 0. This will be the index of 1. We could even have proposal C if you want, like this. For example, should we migrate to Ethereum 2.0? And here, proposal A is saying that yes, we will migrate. We will do a fork. We will fork to Ethereum 2.0 if to. Next one is no until further notice. And C would be something like yes, we will do a soft fork and continue to maintain the existing main fork. So it could be something like this, where there is a proposal A, B, C, and then here the vote itself actually refers to the index of the voter proposal. So you want to actually have the index of the voter proposal, not the number of counts, but you want to say, okay, well, this is voter A, so voter A is Sam, right? What is the address of Sam? Okay, that's me, that's my address. And then what about the vote itself? So if let's say I'm in favor of A, I'm just my unsigned integer vote here, this would actually be at 0. That's the index of the proposal. Clear? So let's remove that. So we also have this weight mechanism, so that some people's vote will count for more than other people in the same organization. So we're gonna have something like unsigned integer weight, and this is kind of just the weight of the voter. So how much would it count? And finally, we want to keep track of whether this person have already voted or not, right? So I want to make sure that there is a boolean saying that this is voted, and if true, then the person have already voted. So whether voter has voted or not. So that's kind of it. So there's the delegate, which is just an address. There's the boolean, which is whether or not the person has voted or not. Then there's the weight, and then there's the vote, which is the index of the voted proposer. Now, it's kind of hard to actually just look at this and understand the whole thing. So we actually need to create a proposer as well, so that we can at least try to, in our mind, we have a picture of how they relate to each other. So let's go ahead and also create a struct for the proposer. So we're gonna say struct proposer, and this is just a struct for one proposer. So this is a custom type for a single proposer. Custom type to represent one voter. To represent a single voter. Okay. And in struct proposer, we have the name of the proposer, just kind of like what I showed you earlier. There is ABC, so we're gonna have bytes 32. This is really, really simple. This is just a short name up to 32 bytes. So in the case of Ethereum, in the case of Solidity, that's gonna be 32 characters. So you don't want to have a very long name here. You just want to have a 32 bytes. Okay, you can keep the 32 bytes there. And we're also gonna have a word count, right? We're gonna have like A, how many votes have there been on A? B, how many word counts are there on B? How many people vote in favor of B? How many people vote in favor of C? So we're gonna have unsigned integer here. We're just gonna have word count. So number of total votes, or you say accumulated votes, by the participants. So now what do we have here? We have a chairperson, we have a voter, we have a proposer, and what we need also is a state variable that helps us map this address to this particular voter instance. Okay, so we want to be able to say, hey, this is the address, can you find me the instance that correspond to this address? So tell me which voter would that be. So if I have 10 voter, I want to just pass in an address and get that. So how do we do that? Well, we have mapping, we learn about that. So we can go ahead now and create also a mapping, and in mapping, we're gonna have our address, because that's what we're going to be taking, right? We say this is the address, and if we pass that onto this mapping, it will find and say, oh, that's actually Sam. So it can point me to Sam. So I'm going to point this to voter, and I've created the voter right up here. And this is also going to be public, so anyone can query for that. It's going to be very transparent, very public, and we're just going to call this voters. So voters is our mapping, not to be confused with voter, which is our struct. And so voters, if you want to call voters, you have to pass in one argument, and that is the address, and the address would then be mapped to a voter, and it will show you, okay, who exactly is that, and return that back to you. And if this is actually a custom type for a single proposer, how do we store multiple proposers together? How do we, if we have A, B, and C? So this is for A himself, right? A, proposer A, then proposer B, another one, proposer C, another one. How do we have a list or an array to have A, B, C together? We learn about that as well, and that's using an array. So there is two kinds of array. There is a dynamic size array, or there is a fixed size array. In this case here, we're just gonna say proposer, and we're just gonna have a dynamic size array. So actually, let's write some comments out here as well. Given address, return voter. Okay, and in this, we're gonna have an array of proposer. So within it, we just have to leave it with nothing, and that would just be an empty array. And then from here, we can say this should be public. Anyone should be able to see all the proposers. So that's about it. So that's the array. If you get to this point, we've created most of the, at least at this point, we think about all the state variables that we need. We created them, we save it, and then now we have the chairperson. This is just a really simple state variable storage. And the value of that will only be modified once, which is during the construction call. Okay, when the contract is first deployed, the constructor executes only once, and that is when chairperson is being set. So whoever is deploying this contract, we're just gonna say, okay, that's the chairperson. And within it, we have the voter and we have the proposer. From voter itself, we want to be able to pass in an address and map out and get exactly the voter. So we created a mapping, and we also want to make sure that proposer itself, it can be put together into a list. So there is a list of proposers. So this is proposer A, proposer B, proposer C, and we have proposers, which is a list, an array of all of this together. So now we can go ahead and just do a Brownie compile make sure that everything still works. Okay, it does. So generating build data, Ballot, and you see the project has been compiled, and we're ready to now start working on the features of this contract. So when you deploy this contract, you want to have proposals that people can vote on. But where do we instantiate all of these proposals? Because if we just deploy this contract, no one can vote for anything. You either create a setter function to set and to create new proposals, or you can just define that directly in your constructor. So when you first deploy this contract, the constructor call is going to run, and from there, all the proposals are going to be propagated. So you're going to just immediately automatically create all the proposals for people. All right. So it's one of two ways. You can either create a setter here, or you can do it in the constructor. I'll show you how to do it in the constructor, but I can talk about that later. Talk about the other method of doing it later, which is to create a setter and a getter. A setter kind of set the proposals. Okay. So in constructor itself, when this contract is first deployed, we want to accept an extra parameter. We want to say, give me a list of all the proposals. So we can use those names of proposals, and we can then scaffold and create all these proposals individually, right? So for each of the proposal in the array that you receive, you want to create an instance of the proposal struct. So in here, we want to receive an argument, and this should be an array. It could be an array. So we just say bytes32 array. This is how you receive it. And now, instead of storage, we're just gonna say memory. So this is storage, yes? Here, we're gonna just say memory. Proposal name. This is something that we spoke about in earlier videos. Now, storage is a state variable. It exists on a blockchain. Somebody can modify the value, somebody can get the value, can set the value using transactions, pay some gas fee. That's storage. Memory, on the other hand, is just this only happens in memory, and it only exists while a function is being called. So it only exists within the scope of this constructor, during which the function is being evaluated. So it only exists while the function is being called. So we're gonna say memory. It doesn't have to be a storage variable, it just have to be a memory variable. And what do we do with proposal name? It's complaining right now. It says this is an unused function parameter. You either use it or you comment it out to silence the warning. So it's saying you're not doing anything with it. You either do something with it or just remove it. Okay, so let's go ahead and do something with the proposal name parameter. So we want to say that if you pass me a list, I want to go ahead and create proposal for you. Okay, so we can do a for loop, and we say for proposal name. So a kind of a pseudocode would look like for proposal in proposal name. This would be the pseudocode. If you're familiar with Python, it would look something like this, and put a colon like this. If this is a pseudocode, this is not Solidity. We're gonna write the Solidity way of doing it, but we're gonna say something like this, and we're gonna take proposals, which is here, right? Proposals, and we're gonna say proposals, and we're gonna say append, or we can say plus, and plus what? Plus the proposal of this proposal name. It takes two things, right? Name and word count, and we're gonna instantiate to 0. So this is kind of the pseudocode for that. If you are familiar with Python, it's saying that, okay, if you pass me this list of all the proposals, then I'm gonna take the proposal for each of them in this list. I'm gonna take that. Actually, we should use the right terminology. We should say array. For each of these items, for each of these elements in the array, I'm gonna go ahead and create a proposal, and I'm gonna append that to proposal list. So proposals list, that's here, we're gonna append that to that list. This sounds simple enough, yes? It doesn't seem too complicated. So let's go ahead and do that, okay? So we're gonna say proposals, or we're gonna say for, and we just have to do this for loop right up here. So we say for unsigned integer, and we say r equals to 0. This is very similar to JavaScript. If you used to writing that in JavaScript, I think the more modern days of ES6, we try to not write this. We have better ways of doing it now, but a lot of those things become map or filter and stuff. But for now, you know, this is kind of bring you back to the days of like C++, JavaScript. We can say for proposal name, and to find the length of it, if it's smaller than that, I++. This is very similar to how you would write that in JavaScript, okay, or TypeScript in the case of unsigned integer here. And with this, you say that create this and then push it into the list, which is here. All right, so this is how we do it. We say proposals.push. Push what? Push a proposal instance. So proposal. So this is the struct. How do we create the struct? We need two things. What is the first thing? The first thing is the name and then the word count. Now, do we have the name? Yes, we do. We just have to take proposal name and then index that, right? So take that and then index it just like this. And then we said, this is the name. So let's put it name here. Let's put name here. And then what do we have next? We say word count. Okay, so let's do word count next. and we want to initialize that to 0, just like this, right? You want to put a semicolon at the end of this, actually not here, but here. You want to put a semicolon here, and that would just be the for loop. So if you save it, it should format, it should auto format. If you did not set up auto format, you can do that. You can just hit Control P and then you can say format document, and it would probably ask you to install a formatter if you, depending on what ID you're using, but mine it's gonna just format out for me. So proposals.push, proposer, and then there's a name, there's a word count. Great. Now we also want to give chairperson a weight because chairperson is also somebody who can vote just like the rest of us. And so we can look at the votes that is here. This is the mapping. So we said, well, in the mappings, take this and then subset for the message.sender. That would give us this, and then with it, control the weight, change the weight to, let's say, 1. All right. So we could do something like this. We can say voters, and we can say message.sender. So voters.message.sender, remember what it's doing is that it's saying that if you, this mapping is saying that if you give an address, I'll return a voter. So return voter, capital V, right? And here within this, we can say, oh, I want to change the weight and give it maybe a score of 2 or score of 1. You can say dot weight, and that would be 2. You know, it counts for twice, but we're just gonna give it 1. And actually, because we have message sender in here already, we might as well just take that and put chairperson in here, so we don't have to repeat that message sender. This is the same as the one before. Message to the sender just became chairperson. So that's the constructor. Okay, so pause a little bit, think about what this constructor is doing. It's saying that when you first initialize, when you first deploy the contract, so take the chairperson, give it a weight of 1, and then do this loop where each of the element in this array is now going to be its own individual proposer, and then they're also going to be passed into this array of proposers. So that's what it's doing. Now that we have a bunch of proposers created in the construction of this contract, when we first deploy the contract, we pass in this proposer names, and it's just going to create ABC, each of them being an instance of proposer, and then you're going to put into this proposers list. Now, what do we want to do with it? We want to give people the rights to vote. If they have no rights to vote, then this is still not doing what it needs to be doing, right? So we want to create a function that allows our chairman or this chairperson, chair lady, to actually assign the right to vote. And how do we do that? Okay, so this is the constructor. We're gonna keep the constructor at the top, and now we're gonna just go ahead and create a function called give right to vote. So anyone who belongs in the organization, they should have a right to vote, and this is something that the chairperson would have exclusive rights to. Okay, so we don't want to make the assumption of who should have the rights to vote or that anyone on the blockchain should have the rights to vote. We don't want to give everyone the right to vote either. So we want to say that the chairperson should be the only authority to decide who has the right to vote, who is in the club, who is in the who have a membership, or who is part of this organization, part of the DAO, part of the DAO. And that's kind of the whole point of that, right? Is to saying that, okay, if you have a right to vote, then it should also be reflected, and then we will know that this person, the vote of this person will count towards that certain proposer. And then at the end of the day, we will find out which proposer has the most vote by looking at the vote count attribute. So give right to vote, what do we need? We need the address of the voter. We want to say that, hey, if I want to give you rights to vote, I need your address. Okay, so this is the address on the blockchain. I need your address on the blockchain so that I can assign you the rights to vote. So I'm going to say address, and this should just be a name called voter. If you want to be more explicit, you can say just underscore voter, and you can say this is external. And so what do we do in here when it comes to give right to vote? We want to first check that only the chairperson can call this function. So we've learned about that in the last video. Remember how to do that? That's actually just going to be a require call, right? So you just say message.sender, because every single transaction there will be a message.sender. I want to check that the message.sender, so whoever is making this function call, that is going to be the same as the chairperson. And we can say chairperson, because chairperson is a variable that is up here. It would check and say, hey, wait, are they the same? Is this address the same as the guy who is calling this function? If it's not the same, you won't even be able to execute even further. And we can pass in an optional message here. We can say this function, only chairperson can assign the rights to vote. So if you're a member of this club, you want to make sure you talk to the chairperson and then pass this address, and the chairperson will then be able to assign the rights to vote to your address, to your blockchain address. And if you have the rights to vote, how do we reflect that? Well, we're going to use the same mechanism that we have here, which is to just give you the weight of 1, and then you can just use the weight of 1, right? So we're just going to say voters, and within it, there is the underscore water. So I'm gonna say underscore water. So this is gonna find, this is waters. It's gonna say, if you pass me address, I'm gonna give you the water itself, right? So we're gonna pass in the water. This is underscore water. So this is from here. And what are we gonna do? We're gonna say wait equals to 1. That's kind of it. So give rights to vote is really quite simple. Just check for that. And then it says, hey, we're saying if this person doesn't have the right to vote, now he does by changing the weight to 1. Obviously, we want to make sure that we don't do this if the person have already voted for a proposal, because if the person have voted for proposal B and you still gave him this new rights to vote and he gets to vote again repeatedly on the same contract, on the same proposal, then that's gonna also defeat the purpose, right? So this person have voted on proposal B and comes to you again and you rerun the give rights to vote function. Now this guy gets to re-vote again and vote again on proposal B. So that's gonna create this bad economy. So you don't want to do that either. So how do we check whether the person have already voted or not? Now remember, we have the voted attribute here. So every time it's voted, we're going to change the voted attribute to be true. We're saying that voted is, if the voted attribute is true, it's saying that, hey, this person has already voted. So this function should not run either. So we can just do another require check here to say that, hey, if the voters, so voters is here, underscore voted, if the person have already voted. So this, you can say if this equals to false, or you can just put an exclamation mark up here to kind of say like this whole thing evaluates to false. Then you can put an optional message. Okay, so what this is saying is that require that this is false, because this is going to be requiring for it to be true. You're saying that, no, I need to require that the voted to be false, because that would mean that this person have not voted. That's why it's a false value, because that's a boolean. It's either true or false. If this person has already voted, I want to say that the voter has already voted. Okay, so if this is true, meaning the person has already voted, I want to make sure that that person should not be able to vote again. So I misspelled this. It's supposed to be voter. So just like this. Just to save ourselves a little bit of gas cost, we can also make sure, we can also do another require. We can say require that, and require what? Require that this, the weight of that should be 0. Because if it's 0, if it's not 0, then you don't even have to do this. So require, just pass in an optional message saying that already has the right to vote, or voter already has the right to vote. Okay. So require is kind of a nice way to just catch for all of this, because it's a good idea to just use require, and if the first argument of require evaluates to false, execution is just going to terminate. All changes to the state and all of the ether balances are reverted. This used to consume all of the gas in old EVM versions, but not anymore. So right now we can use this to say if require, and if it's not true, or if this condition doesn't pass, right, then just revert, and you don't have to worry about it taking up all your gas anymore. It would just refund any gas that's not used. So this is kind of a good way to just check for that. And then finally saying that if all of these checks pass, then finally just assign a weights to vote. So now we're merely giving people the rights to vote. We're not actually asking them to vote yet. There is still no function to actually vote and to modify the state of the vote count, because only in vote do we actually modify. And when we vote, we're actually going to change the value of voted, and we're going to change the value of vote count as well. So that's something that we need to implement next, is that right now it's just a rights to vote, it's not actually voting. So let's do that. Let's go ahead and just call this function vote, and it takes unsigned integer, and it takes a proposal. So if you want to vote, so let's say person A voted for proposal B. So proposal B, this is an index, right? I said that A would be index 0, B would be index of 1. So here we need an index of that. So proposer. And this is going to be an external function, so that anyone can call this function, because if it's not external, then nobody could call this function. Only the contract itself could call the function, and it's not going to be very useful, is it? So we want to make sure that, okay, this is external, so anyone can call this function. And again, I like to just keep this with an underscore in front, just to tell myself, okay, that's the parameter that I'm accepting, and it should only work within the scope of this function. And within it, I'm going to go ahead and say, first create a voter. And within it, just say sender equals to voters message.sender. So I'm doing very similar to what I have up here. I'm saying that the message.sender, I'm saying the message.sender itself, in the constructor, whoever called this function, which can only be the guy who deployed that, chairperson. Here, whoever is calling this function, let me just put a semicolon so it doesn't complain here. Just create this sender variable. Now it says that data location must be storage, memory, or call data. Storage is a variable that is on the blockchain. It's a state variable. It's a state variable that is stored on the blockchain. Memory is just happening within the memory itself. So what do we want here? What is the appropriate choice here? Now the appropriate choice is to have it as storage. So water storage sender. So water storage sender is gonna go all the way up here. This is the water itself. This is a storage water, and it's gonna say take that, and now you have a sender, and this sender is a variable that we can then use in here, and that would just be assigned to water's message sender. Okay. So really the meat of this function is we want to take the proposer. So we're gonna say proposer. We should do what? We should say take the word count of this, which is here, right? Take the word count of that and do what? Just add. You can say plus equals to 1. But remember, if we do that, then we kind of defeat the purpose of the weight. So what we want to do is to use the weight instead. So we want to say sender.weight, which is gonna find, okay, this is the sender, which is here, and this sender itself is from the waters and then message to sender. So it's gonna find the waters here, which is gonna go into this one if you pass in an address, and then it's gonna say take the weight of that and just gonna add this, right? So this is kind of the meat of the function. But we also want to do our require, because what if this guy have no rights to vote at all? So we want to make sure that this guy or this girl have the right to vote. So let's maybe do a require statement here, and we're gonna say sender.weight. First of all, want to make sure that that's not 0, or that it has even greater than 0. Okay. Otherwise, we're gonna say no rights to vote. So if you're trying to call this function, but your weight, meaning the address associated with your account, your weight is actually 0, then no rights to vote. Then what else? We want to check that this person have also not already voted. So I want to say sender dot, is it called voted? Yes, it's called voted. So let's just say voted, and we want to say that, okay, if this person has not voted, all right, so we want to do the same thing as we did here. So I want to say this person has not voted. So we want to put an exclamation mark in front, and that would just negate that, and then we said already voted. Also want to put a semicolon at the end. So this is what it's doing, right? It's saying that first of all, check whether or not you have the rights to vote. Second, that you have the right to vote, but you have also not already voted. And then what else do we do? What we need to do next is, if these two conditions pass, then it will come here and it will vote. But we need to change the voted to now mark that as true. So I want to make sure that sender.voted is now true, because if we don't do that, then this person is still going to have a false, and this person can repeatedly hit the vote function and vote multiple times, and that is really not the kind of thing we want. So let's take a look at sender, and sender goes into voters, voters go into voters. So this is all of this, but we also actually captured the index of the voter proposer. So we have the vote, so we also need to set some values in here. So this is the voter, we're not setting any value, so let's do that as well. Let's go back in here, and let's say sender vote equals to the index of the proposer. Now I said this is the index of the proposer, so let's just say index of the proposer here. Okay, so that's about it. That's the vote function. At this point, we have a bare minimum contract that at least allows you to create proposals and then assign the rights to vote, and then other people who have been assigned the rights to vote is now able to vote. So we have now maybe 80% of this contract done. We have maybe remaining 20% of that. So we talk about what if folks want to be able to delegate their votes and said, hey, I don't want to be exercising my right to vote, but I want to delegate this to somebody else. So we want to have that function as well. And this is probably a more complex function than the one in here that we see in votes, but we're going to try and go ahead and do that. So let's go ahead and now create function delegate. We don't know what we want to take yet, but let's think about this. And we say this is also external. Most of these functions are going to be external, because if you don't put it external, nobody can actually call that in a transaction. They can't make transactions to go and call this function to perform some sort of state change in your contract. So delegate, what do you want to do here? So we're going to try and repeat very similar patterns here. We're going to first take water storage sender, going to send that, put this in here. So just copy and pasting from the earlier word function. And then we want to set up our requires. So just like what we did in the word function below, we want to say that first require that this person have not already voted. So what we want to do is to say sender.voted, just like this one here. And we're also going to put the same message to say this is also already voted. But here it's delegating, so we're gonna say you already voted, cannot delegate. All right, so if you already voted for proposal B, you cannot delegate your vote to somebody else. And in this case here, vote is kind of the same thing. We can just say you already voted. Okay. And we also want to make sure that if this person is trying to delegate, it needs to delegate to somebody, and that somebody we can call it address, and we can call it a delegate. We can call it delegator, delegatee, but we can just make it simple and just call it to. Who do you want to delegate this to? So we're gonna just say address, and we're gonna put to. And here we're just saying that make sure that the to is not you. So we want to say require that sender message.sender that's not the same as to. So you cannot call this function with your own address, because then you're just delegating to yourself. So you can just say you cannot delegate to yourself. Okay, so if you call this function, you have to pass in somebody else's address. If somebody else's address, that somebody could then vote in behalf of you, because that person will now have some weight in the vote, but you cannot delegate that to yourself. That doesn't make sense. And just to be consistent, we're also going to just put an underscore in here. Just put an underscore in here. Right? Next, we're just going to create a variable to just hold this person, this two. We say that if these two conditions have passed, then we know that, okay, now this is a legitimate delegate. So we can say water, and we're going to do the same thing as what we have here. So storage, and this person is now a legitimate delegate. So we're going to say delegate. We're also just going to put an underscore, delegate. And that would just be a waters 2. But since this is storage, we probably don't want it in front. We're probably just going to keep it behind like this, delegate, right? Because then if we put something in front, we're just going to assume that it's going to be in the memory, just to take away some cognitive load there, right? So we're going to have water storage delegate, but this will only be called if the two conditions have passed. So now we have the sender and we have the delegator. Sender is somebody who called this function, who said, hey, I want to be able to delegate my vote to somebody else. And delegate is the receiver end of this relationship. So that person would then be delegated and would then be the delegate to the sender and be able to exercise the rights. In the case of this smart contract, we want to make sure that anyone who you can delegate to anyone, so long that the other person also already have the right to vote in the first place. Okay, so we want to say that you can delegate to anyone as long as that person already have the right to vote in the first place. How do we check if that person has the right to vote? Now we see give rights to vote. How do we know that person has the right to vote? We check for the weight itself, right? Because give right to vote, we just change the weight to be 1. So if the person do have a right to vote, the weight should be 1. And so here we want to set up a condition and say that delegate to anybody as long as the delegate has rights to vote. And we know that by just checking the weight itself. So let's go ahead and say require again. And what do we want to require? We want to say the delegate itself, the weight of this person should be greater than 0. So if it's 0, it doesn't count. All right. So this is where rights to vote comes into play again. So in other words, you cannot delegate to any wallets that has no voting rights in the first place. And once this is checked, now you want to perform the actual, this is where you do the actual delegation. But before you do the actual delegation, let's just remove and just count you as already voted, because when you delegate to someone, you gave up your rights to now vote. So we're going to say sender.voted, and now that's going to be true. So sender.voted equals to true. It's just saying that, okay, now that you have delegated, it's the equivalent of you having voted already. So you no longer have the rights to vote, because you cannot delegate to someone else and then also then use your own voting rights to then vote for the same proposal, right? So I want to say that, okay, sender.voted equals to true. You gave up the voting rights. You just delegated to someone else. And in the sender itself, we also see that there is this delegate. So we want to set the delegate to this address. We want to say that this is the person delegated to vote on your behalf. Okay, a little bit too verbose here, but just to help your understanding. So we want to say sender.voted equals to true, and we want to say sender.delegate, and we want to say sender.delegate. That would just be the to address, which is from right up here. Now this is the actual delegation itself. So we want to check for two conditions as well. We want to consider two different scenarios. The first scenario is that if the delegate did not vote, have not voted yet, then what do we want to do? Then the second scenario is two scenarios. First, if the delegate has not voted yet, what do we do? Then the second scenario is that if the delegate already voted, what do we do? So there's two scenarios here. So what do we do with the first scenario? We said if the delegate has not voted yet, So we can just say if, and we said not voted, so exclamation delegate dot voted. So this is saying that if the delegate has not voted yet, all you need to do is to just give this person the weight, because then it will count as yours as well. So plus equal to sender.weight. So what I'm saying here is that, let's say a person A has weight of 1, person B has weight of 1, and when you person A delegate to B, what should happen? Now person B has a weight of 2, and this would then change the outcome of the vote count, because when you do a vote, it will take the weight and add that to the vote count. So this is what we're doing. We're saying that, okay, we'll take your weight and add that to sender.weight. You don't want to actually set sender.weight to be 0. You don't actually want to do that, because you still actually have the rights to vote, except we just have to mark you as already voted. So we just mark you as having already voted. You don't want to change the sender.weight and change the weight to be 0, because that's just going to take away your rights to vote. So that means that's just going to undo this rights to vote as well. So you want to think clearly about what you write here, right? So you don't want to do that. Just going to go to an else statement now. We're saying else, do what? Move this up here. If the delegate has already voted and you decided to delegate to this person now, what is going to happen? Well, what could happen is to basically take the vote count of the proposer and basically add to that. So you can take something like this and copy this and paste it in here. And so you have proposers, and this is not going to be proposer anymore. This is going to be the guy that the proposer that the person voted for, right? So you're going to say delegate underscore dot vote, and the rest is the same. So what this is doing is it's going to go up here and look at what is the index of the voted proposer, take that and then just add to the same thing the weight that you assign. So if that is 1, it's going to add 1 more count to it. If your weight is 2, then it's going to add 2 more counts to it. Right? So if the person has already voted, then whatever it is that the person is voting, take that and then look for the vote count of that proposer and add to it the weight that you're delegating. So that's the two scenarios. So let's take a look at this function that we just wrote, which it says that, okay, to perform delegate, you first need to make sure that you haven't already voted. So make sure that you haven't already voted. If you already voted, you cannot delegate. And then you also cannot assign that to yourself. And once these two conditions are cleared, then you created the delegate variable. Within the variable itself, you map it to whoever this address is within the voters array itself. And then it then check that this person should already have the rights to vote. So you cannot delegate to anybody who have no rights to vote. And from here, we say that, okay, now check that now change the state variable from voted from false to true. So this will, the next time you try to delegate again, you can't do that anymore, because it would then hit this line 50. Okay, so line 57 is really crucial here, so that you don't get to delegate multiple times over and over again. And sender.delegate, and so this is gonna be the guy that you delegate to. So once you clear this condition, you get to execute this and you get to execute this. So sender.delegate, we also store that on the blockchain. So anyone can see, oh, this person A, have delegated that to person C. And we know that, and this is going to be very transparently recorded on the blockchain. And we check for the condition, we say that the actual delegation process looks like this. If the person have not voted, then simply add the weight to this delegate and let this delegate do whatever you want with the weight. So maybe at some point he decided to vote for C, vote for A, whatever it is, his weight is now going to bear your weight as well. So if your weight is 1 and another person delegate to this person and the vote is 1 as well, and then his own weight is 1, then now he have a weight of 3. So whoever this person is voting for have a lot of power to shape the discourse of the decision in favor of C. Else, then what you do is to just say, okay, then look at what he has voted for and just add to that your own weight. So if that person already voted for C and C currently have 7 votes, and you delegate to this guy, and this guy voted for C in the past, now C is going to have 8 because your own weight is going to be added to that. Depending on whether there is a need for this, you may also want to just create, maybe between this voter and the require statement, you want to also do another require statement to prevent any kind of loop. So if you want to, let's say, prevent loop in delegation, so this is a scenario where A delegate to B, B delegate to A again. Okay, so, or B delegate to C and then C delegate to A, or however we want to do this. And you can check for this condition using a while loop. So you can do something like while, and you can say while what? You can say while voters2. While voters2 what? Check that if this person's delegate, while this is not true, so if this is not 0, which means it's never going to be 0 because 0 is just the default value, right? The initial default value. So it's going to have to loop through it. While this is not true, then set the 2 to voters underscore 2 delegate, and then check for require, and require underscore 2, make sure that this is also an underscore in front. It's not the same as message.sender. And now we need to move this down, because if we don't, we're actually manipulating the value of 2, and that is going to change this. So we're going to move this down here, and want to do a require, put a semicolon, and put a semicolon up here as well. So this is kind of preventing a loop in delegation. So you can put an optional message saying that found loop in delegation. Okay. So address 0 is kind of the default value when you first initialize the state. If you create an address state variable and there's nothing in there, then it's just going to be address 0, which is to say 0, 0, 0, 0 all the way, right? So what this while loop is doing is saying that, okay, there is a list of voters, right? Take the 2 and look at the delegate of that. And it's saying that if the person delegates, so this is the 2. So if A is delegating to B, now we're looking at B. And we're looking at B.delegate. Is the B.delegate, is that the same as the message.sender? So A delegate to B, A is the message sender. In this case here, A is message sender. And just to make sure this is all clear to you, and if you look at B, what is B? B is basically the 2, right? So you can take this and just copy that. So B is voters 2. So it's saying that, first of all, when you first run into this loop, check that the 2 is not message sender. So in this case, you're checking that B is not actually delegating back to A. All right, so it's checking for this condition, and if this condition is not met, immediately run an exception saying found loop in delegation, and so none of this will continue to execute. And it says here, continue to, if this is not the case, then continue to run the while loop. And in the while loop, this is going to be updated. So for example, now it's going to look at the delegate. So if B is actually delegating to C, now you check for C and see whether C is delegating back to A. No, it's delegating to E. Now check if E is delegating back to A. So it's keep on doing this to make sure there is no loop in delegation. So typically, you don't always want to use a while loop. Solidity documentation itself says that while loops itself, they are in general are very dangerous, because they can run for too long and they will consume a lot more gas than is really required in a block. In this case here, the delegation will not be executed, but in other cases, such loops may cause a contract to then start completely and burn up all your gas. So in general, don't wanna, if you can choose not to use a while loop, don't use a while loop. All right. So that's kind of it. That's kind of a delegate. And we are gonna now save this just to make sure all of this still compile. Let's go ahead and run a Brownie compile. Okay, all of that still works out. So now what do we have? We have a constructor. Initially, when you first deploy the contract, chairperson is going to be set to whoever is sending the contract, is sending this transaction, the contract creation transaction. So whoever is sending the contract creation transaction, that person is going to assume the role of chairperson. And from there, you will give rights to vote, because if you don't have any rights to vote, then all of the proposals doesn't matter. So within the constructor, we have all the proposals being created. We have the chairperson. The chairperson can give rights to vote, and then folks can exercise their votes either by delegation or by voting themselves. And so we wrote all of this logic, and now we have a pretty good contract to then start to iterate and play around and test with. But before we do that, we also want to create a winning function to determine which proposal should be the one that has the most amount of votes. So this should be a pretty simple proposal. It's just going to look for the amount of vote counts, and it's going to say, okay, which proposal among them have the highest vote count, and then declare that as the winning proposal. So let's name our function winning proposal, and we're going to create some space here. Say function winning proposal. This is also going to be a public function, because then no one can see it otherwise. We're going to have to return something. Returns something. And what is it that we want to return? So in this case here, we just want to return the index. of the winning proposal. All right, so we just gonna, this would just be an unsigned integer. If you look at all the way up, you see that it's just an unsigned integer. So let's go ahead now, and we're gonna say this is the winning proposal. Oops. And we just have to create the variables first. So let's go ahead and say there is a winning proposal, because we want to return this, so it needs to appear here, and we need a winning vote count, right? And here we can just do a for loop. So again, in Python, this is kind of how we do it. We say that for proposal in proposals, so think about how you do it in proposal. You say that maybe set this up, default value is 0, and then you say that if the proposal itself, if the proposal word count is greater than this, then that would become the new winning proposal. Yes, so we're gonna go ahead and say, then take the winning proposal word count. Now that would just be the proposal.word count itself. And so it would run through. It says proposal A. It says proposal A, do you have a higher word count than 0? Oh, of course I do, right? So proposal A now will become, if proposal A has 4 votes, now the winning word count will be 4. Then it looks for the next one, because this is a for loop, remember? So B will now say, B, do you have more than 4 votes? And B said, no, I don't have, I only have 3 votes. Well, then it won't be that. So then A will continue to be winner, and then you check for C, and then check for D, you check for all of the proposal in this iteration here. So for proposal in proposals, keep checking that. If it's a higher one, then declare it as a winner. How do you declare it as a winner? All you need to do is to set winning proposal to be the proposal, and that's it. So this is how you do it in Python. But how do we do this in Solidity, right? So how do we do this in Solidity? You say for, you say unsigned integer, and you have p equals to 0. You can have I equals to 0. Earlier we used I because that means index, that stands for index. You can stick to I if you want to. I'm just gonna say p now, stands for proposal, and I'm gonna say proposal.length, similar style of writing this for loop as what we did above, and we're gonna say p++. You can change all of this to I if you want to. If you want to just keep to I, you can do that. Okay, so this is kind of doing the for loop up here, and then we're gonna just say check for the condition. It said if proposals p, this is the index, remember, dot word count, is that greater or not? If it's greater, then change that to winning word count. Now we haven't really accounted for the fact that what if there is a tiebreaker? What if there is a tie? You know, so you don't want to actually put equal now, because then if A has 7 votes and B has 7 votes, and now B is gonna override that. So we don't want to do that yet. We may think about how do we solve that later, but for now we're just gonna say there is no, if A and B are both 7, then B will not replace A as the winning proposal. Okay, and then we're gonna say winning proposal, or you can do one of two. You can start from winning proposal first. You can do this line first, then do this line, or you can do this line first, 104, before you go to 105. So maybe let's do the word count, and we say word count would then just be the proposals p dot word count, and that would accomplish what we have, line 104. Then what next? If this is the case, what next? Winning proposal will now also be, did we name it? Yeah, we did. P. And so since we already declared this, it's complaining here, we just have to remove that. It's saying that since you already declared that, you probably don't need to do it both sides. So we have winning proposal up here, and we have winning proposal there. And it's also complaining because winning proposal, and this is the same name here, so we want to add an underscore here. And so we just want to add an underscore here, so that winning proposal is a function, and it's always going to be a function and not anything else, right? So we can do this. And all is left to do is to just create a declaration of the winner who is winning. Okay, so there is the function winning proposal. So now final step is to just create a winner and just say who is the winner of this among these proposals. So I want to just say function winner name. This is going to be external, and typically this could be it. We could just return, I guess, this, and we can write our function in here. But I know that winner name is not something that you want to modify. It's not something that you can't, you know, make a transaction and create and change or any of this. So we want to make this a view function so that it could be free. So anyone could just get the winner without actually incurring a transaction, because you're not modifying any value on the blockchain or within the smart contract state itself. So we want to return, what do we want to return here? So we want to return the same thing up here. We want to say that the proposal itself, but I think a better idea is to, instead of returning the index, let's return the name, and the name is a bytes 32. So we're just gonna return the name of that, because it's not really helpful to return. I mean, it is helpful. You can return like index number 3 win, right? But it's better if we say the proposer is, let's say the proposer name would be something like, for example, let's put an example, something like migrate to F2. So this is a much better name if you're coming to declaring the winner name itself. So let's reflect that. Let's say bytes 32, copy all of this, go all the way down, and this is winner name. So you can call it winner name, but you don't want it to be the same as the name of the function. So you're just gonna add an underscore here, and what we're gonna do is say we're gonna just return the winner name itself instead of the index, the return name itself. And what we're gonna do here is we're gonna say winner name underscore equals to, now take all the proposers, take the index of the winning proposer, I know there is just a placeholder right now, and take the name of that, because the name would then just return exactly bytes 32, and that would be exactly what we need to return, and that would just be a view function. But do we have index of winning proposer? We don't have that yet. So you can either go ahead and create index of winning proposer, and you can set that to something, or you can just go ahead and call the winning proposer function up here. So let's do that like this, and want to make sure that this is also a view function. So this is free and this is also free. So now we have the full winner name function written. So this is gonna execute winning proposer, but winning proposer, lucky for us, is also a view function, so also doesn't incur any gas, and it will give us the one with the highest vote going through this for loop, which is doing this in Python, and then finally returning the name of that. And so we have it. So this is the ballot function. And now what we need to do is to just sort of test it within the terminal, within the console, and that's for us to know that ballot is working as we intended. Okay, so that's all I have time for today. In the next episode, we're going to be starting to write some tests to test our ballot contract, make sure that everything works as expected. And when we're done with that, we can try to deploy this onto a real blockchain that anyone can interact with and get some values and set some values. So if you're excited, stay tuned, make sure you subscribe to the channel, make sure you share this video with somebody else who would find this helpful, and I'll see you in the next video.